In the last class, we discussed about the concepts related to the common roots, and now we are going to solve problems based on common roots. Okay. See, I mentioned you these problems in the last class at the end to solve, and now I will start this class with these problems. Okay. First of all, you just think about the 16a. Okay, the first problem of 16. What it is saying? See, ABC are the reals. Okay, it is very clear that ABC are reals. And the equation ax square plus bx plus c is equals to 0 is one equation. X square plus 2x plus 4 is equals to 0 is another equation. These two equations have a common root. So these two equations have a common root, and we have to find the value of a plus c divided by b. Okay. So how can we find this particular value a plus c by b? And one more thing, the question is saying that these two equations have a common root, right? So I need to observe some aspects related to the roots which we discussed earlier. First of all, you just think about this particular equation, x square plus 2x plus 4 is equals to 0, right? What you say about the discriminant of this x square plus 2x plus 4 is equals to 0? The discriminant of this equation is simply nothing but b square minus 4ac, and it is very clear, you just calculate. Okay, b square is 2 square, 2 square minus 4 into a means the coefficient of x square and the constant c means 4. This discriminant is clearly less than 0. Since this discriminant is less than 0, the roots of this equation are conjugates to one another, complex conjugates to one another. And for suppose if one root of this equation is p plus iq, then for sure the other root of this equation is also p minus iq. Okay. Now the question is saying that these two equations have a common root. Since these two equations are having a common root, for suppose if you say p plus iq is a common root, then automatically you will get p minus aq also as a common root, because ABC are reals. Because ABC are reals, then for this equation ax square plus bx plus c is equals to 0. If complex root exists, they are also complex conjugates only. Okay. If one root is common, okay, you need to combine these two words. This equation has a common root with the second one, as well as the coefficients of this equation are real. When you combine these two, if any one of these two will become a root for this, then automatically other root its complex conjugate, because ABC are reals, and that's why this first equation also has roots of the form p plus iq and p minus iq. The question is saying they have only one common root, but when you analyze, these two equations will have two common roots, because the roots of second equation are conjugates, as well as the coefficients of first equation are real. And at the end, since these two equations have not only one common root, they have two common roots. Okay, since they have two common roots, it is very clear that the coefficients are in the same ratio. So we may say this coefficient x square and this x square coefficient 1, a by 1 is equals to b by 2 is equals to c by 4. Whenever a by 1 is equals to b by 2 is equals to c by 4, easily we will write that a is equals to some k, b is equals to 2k, c is equals to 4k. At the end, to answer for this problem, for the space I am searching, yeah, a plus c by b. What is a? It corresponds to some k, because a by 1, b by 2, c by 4, all the three are equal. You just say they are equals to some k. So k plus c is some 4k, b is some 2k. When you solve, you will get your answer as 5 by 2. Okay, just have a look. Okay, once again I repeat for you, these two equations have one root common as they mentioned, but when you think these two equations have two roots common. Since these two equations have two roots common, as per our discussion in the last class, the coefficients ratio is what? Same. And that's why what we have, since the coefficients ratio is same, the coefficients of first equation are ABC, as well as the coefficients of second equation are 1 to 4. So ABC and 1 to 4 are in the same ratio, and that implies we say that a is equals to some k, b is equals to some 2k, c is equals to some 4k, because these three coefficients are in the same ratio with these three coefficients. So that implies we need to calculate a plus c by b. So what is a? A is k, c is 4k and b is 2k. When you solve, you will get your answer as 5 by 2. Okay, there ends this first problem A, and then I am going to solve B. Okay, just have a look. Now 16A. In this problem, x square minus 11x plus a is equals to 0 is one equation. X square minus 14x plus 2a is equals to 0 is another equation, and we need to find a common root. So to solve this problem, we may go with the common roots condition, or you may use any direct procedure to solve the problem. Okay, I will solve in two ways. First, I will use the common roots condition. Okay, so what is the common roots condition? I think in the last class we mentioned it. What is the common roots condition? So if two equations have a common root, then the condition on that condition is the determinant of AB PQ into determinant of BC QR into is equals to determinant of CA RP whole square. Okay, in this A, B, C are the coefficients of one equation, P, Q, R are the coefficients of second equation respectively. So that implies determinant of A, B, C. First of all, the coefficients of first equation are what? 1, minus 11 and A. So 1, minus 11 and A, you need to write them consecutively. 1, minus 11 into minus 11 A is equals to A and 1. So since these are the coefficients, you need to write them consecutively. And then the coefficients of second equation, 1 minus 14 and 2a. Again you just write like this, 1 minus 14, 2a, and then 2a, 1. Okay, so now we need to simplify this part. So that implies, so what is the determinant of this? As I mentioned you, this determinant is simply nothing but AD minus BC. 1 into minus 14 is minus 14, minus of minus 11 is plus 11, so you get that value as minus 3 into, whereas coming to this, minus 11 into 2a, minus 22a, minus of minus plus 14a, minus 22 plus 14 is minus 8a is equals to, what is the determinant of this? A minus 2a. AD minus BC. A minus 2a is minus a, and that is minus a square. Okay, so we need to solve it. How can we solve? This is equals to what? 8 3 is 24. 24a is equals to a square. Okay, when you cancel out that a, you will get that a is equals to 0 or 24. Okay, we have two options, a is equals to 0 or 24. If you replace a with 0, it is very clear these two equations have a common root 0. Whenever a is 0, this equation will become x square minus 11x is equals to 0. That equation will become x square minus 14x is equals to 0. Clearly 0 is the root for those two equations. And whenever a is equals to 24, we need to think about it. Whenever a is equals to 24 here, okay, you just think about it. If it is 24, what is the equation? You just think in your mind. If it is 24, this equation is x square minus 11x plus 24. The roots of this equation are 8, 3. Okay. Whenever this is 24, this is 2 into 24 is 48. Okay. So we need to think for 48. Then, yeah, the roots of this equation are 8, 6. Here 8, 3, there 8, 6. So 8 is a common root. So at the end, you don't need those roots. You need the value of a if the equations have a common root, and that's the procedure. As we discussed in the last class, this is a common roots condition. When you apply this condition for these two equations, on simplification you have the value of a as either 0 or 24. This is a direct way of solving the problem using common roots condition. In another way, without using this condition, if you don't memorize this particular condition, you have another choice to solve the problem by the regular procedure. In that way, I will solve now. Okay, your answer at the end is 0 or 24. Method 2 I will explain for you now. Okay, yeah, just look at the board. What to say about method 2? As I mentioned you, just we discussed method 1. where we discuss, yeah, direct problem, and now it is method 2. So to solve method 2, since these two equations have a common root, you just say the common root as alpha. Okay, whenever, since the common root is alpha, it is very clear that alpha square minus 11 alpha plus a is equals to 0, because root must satisfy the equation. And you replace here alpha square minus 14 alpha plus 2a is equals to 0. Okay, from these two I need to get the value of a. So how to proceed? We have different procedures. I just do subtraction. Okay, minus, plus, and then minus. Okay, if I do subtraction, what will happen? This alpha square and alpha square get cancelled. 14 alpha minus 11 alpha is 3 alpha. A minus 2a is minus a is equals to 0. Since 3 alpha minus a is equals to 0, it is very clear that alpha is equals to a by 3. And since alpha is equals to a by 3, now you just replace that a by 3 in any one of these two equations. So now if you replace in the first equation, x square is a square by 9 minus 11x. X is the alpha, alpha is a by 3. So 11 a by 3 plus a is equals to 0. So if you just multiply everything with 9, if you multiply everything with 9, it becomes like a square minus 33a, okay, plus 9 is equals to 0. A square minus 33a plus 9 is simply nothing but a square minus 24a is equals to 0. And since a square minus 24a is equals to 0, a is equals to 0 or 24, and that's your answer. Okay, in method 1 we solve the problem by using the condition on common root, and now I solved it just without using that condition with a regular procedure. Just have a look. So that's the way to solve the problem in two different ways. One is the direct way and the other one is the formula way. Okay, so at the end your answer for this problem is 0 or 24. If you do in any way, you will get the same answer, right? No problem. So this is 16b. Now I have another 3 questions in 17. We need to discuss one by one. Okay, so just look there. Yeah, so 17a, 17b and 17c, one by one we need to discuss. So what to say about this 17a? Just look at the problem. Two equations are given here. One equation is x square plus bx plus c is equals to 0, and the other equation is bx square plus cx plus 1 is equals to 0. These two equations have a common root. Since these two equations have a common root, we need to show that b plus c plus 1 is equals to 0, b square plus c square plus 1 is equals to b plus c plus d. Like that we need to show. So how can we proceed? See, since the problem involves with completely in terms of b and c, to solve it, better if you go with the common roots condition only. Okay, once again I repeat for you, you just don't bother about that a, b, c and dc, a, b, c. Okay, as per that condition, if first equation is ax square plus bx plus c is equals to 0, and the second equation is px square plus qx plus r is equals to 0, then we have this particular condition. If you have any doubt related to this condition, you just refer last class. Okay, right. So here I am using the capital letters, no problem what you are using, either capital or small, no problem. Okay, first equation is ax square plus bx plus c. Okay, yeah, c a square, and second equation is px square plus qx plus r. So pq and then qr and then rp whole square. So very simple to memorize actually. Okay, this is a common roots condition. Now how to solve this particular problem? So this implies I have two equations. The coefficients of first equation are 1 b c. So I need to replace a with 1 and b with b and c with c. So 1 b into b c is equals to c 1. Okay, and I have square for this. Next, the coefficients of second equation are b c 1. So in a circle I need to, in a cyclic manner I need to use this b c 1. Okay, BC and then C1 and then 1B. Okay, now you just apply that determinant technique. So what is the determinant of this? AD minus BC, that in the sense C minus B square. So this implies C minus B square into, and here see B minus C square. What? B minus C square. So B minus C square is equals to, and here BC minus 1 whole square. What we have here? BC minus 1 whole square. So first of all, just look there. I will erase this for the space. Okay. Now at the hand, when you apply common roots condition for these two equations, now you have that C minus B square into B minus C square is equals to BC minus 1 whole square. We need to simplify it, and at the end we need to show that B plus C plus 1 is equals to 0 and B square plus C square plus 1 is equals to B plus C plus BC. You just so this implies C into B is BC minus C cube minus B cube, and minus B square and C square is plus B square C square is equals to this side B square C square minus 2BC plus 1. Is it clear? Yeah. So what I need to do? This B square C square and B square C square gets cancelled, right? And then I will rearrange it. How can I rearrange? Just have a look. Now this implies, I will send everything that side. B cube plus C cube plus 1 minus 3BC is equals to 0. Just pay attention on this particular statement. B cube plus C cube plus 1 minus 3BC is equals to 0. From there, I am going to generate these two. Okay. Once again, I explain for you, and I will erase this for the space concern. Okay. So these two equations have a common root. That's the given problem. So I just applied a common roots condition for these two. So this is the common root condition. So when I replace the values, see the coefficients of first equation are 1BC. So 1B, BC, C1. The coefficients of second equation are BC1. So BC, C1 and 1B. So when you apply that common root condition in a determinate way, at the end you have that B cube plus C cube plus 1 minus 3BC is equals to 0. Now use this to generate it. It is a simple algebraic way. I think you all aware about that particular formula. What is that form? Yeah. A cube plus B cube plus C cube minus 3ABC is A plus B plus C into A square minus B square minus C square, like that. Okay. So this implies continuation from there. B cube plus C cube plus 1 cube minus 3 times of B into C into 1 is equals to 0. So it is just of the form x cube plus y cube plus z cube minus 3xyz. So that implies x plus y plus z. So b plus c plus 1 into x square plus y square plus z square minus xy in the sense bc, yz in the sense c, zx in the sense b is equals to 0. So this product is 0 means either this is 0 or this is 0. So either this or that. So you have two conditions. Okay. Just have a look. This is the way of solving this particular problem related to the common roots. Just have a look, and then I will solve 17b. 17b. 17b is somewhat simple problem when compared with the previous one. Okay. Here the equations are x square plus ax plus b is equals to 0, and another equation is x square plus bx plus a is equals to 0. They have a common root, and we need to find a plus b value. So again we have two options. One is to move with the formula, and the other one with the procedure manner. Okay. See, since these two equations have a common root, now I am going to solve in method 2. That in the sense with a regular procedure, you just take that the common root is some alpha. When you say the common root is some alpha, that alpha must satisfy these two equations. So replace x with alpha in the first equation. You have that alpha square plus a alpha plus b is equals to 0. And since alpha is a root for the second one, so replace alpha in the second equation. Alpha square plus b alpha plus a is equals to 0. You just do subtraction. Minus, minus, minus. So here what will happen? When you are subtracting, this alpha square and alpha square will get cancelled. Here a alpha minus b alpha. Just think once. So this is a minus b times of alpha. plus b and then minus a. So this is b minus a is equals to 0. So a minus b alpha plus b minus a is equals to 0. Now just look there. When you common out a minus b, what will happen? If you pick out a minus b, so in the bracket you need to write alpha here and corresponds to this b minus a minus 1 is equals to 0. A minus b into alpha minus 1 is equals to 0. So if you fix that a and b are not equal, then it is very clear that alpha value is 1. Either this is 0 or that is 0. If you say that a not equals to b, then for sure you have that alpha is equals to 1. Okay. So since alpha is equals to 1, you need to replace alpha in any one of the equations. Now, if you replace in the first equation or in the second equation, 1 plus b plus a is equals to 0 and your value of a plus b is equals to minus 1. There ends the problem. Okay. For this problem, if you go with the technique, procedure, formula of the common root, so it becomes somewhat lengthy, right? So if you move with this procedure, then only the problem, you get the problem in an easy manner. You have two options, either move with the formula or move with the procedure. Okay, some problems require the formula and some problem require the procedure. This is a problem which requires the actual procedure to solve. Okay, have a look. Now the next problem. So ax square plus bx plus c is equals to 0 is one equation. Bx square plus cx plus a is equals to 0 is second equation. Cx square plus bx plus a is equals to 0 is third equation. These three equations have a common root. You just say alpha is a common root. Whenever alpha is a common root, alpha must satisfy the equation. So from the first equation, a alpha square plus b alpha plus c is equals to 0. Second equation, b alpha square plus c alpha plus a is equals to 0. Third equation, c alpha square plus b alpha plus a is equals to 0. From these three situations, from these three equations, I need to eliminate alpha, I need to establish a relation on ABC. So my idea is just add these three. Add. If you add, what will happen? A alpha square, b alpha square, c alpha square, then it becomes like a plus b plus c times alpha square plus b alpha, c alpha, I do some mistake somewhere, okay? A, B, C, B, C, A, here it is not C, B, A, okay? It must maintain a cyclic order, it is C, A, B, right? And that's why you need to take here A alpha and here B, okay? There is a small mistake there. Cx square plus Ax plus B, okay? When you add these three, again you will get that B plus C plus A into alpha. Plus, when you add these constants, you will get that C plus A plus B is equals to 0 again. And once if you look, A plus B plus C is a common thing. So you have a chance to rewrite it as A plus B plus C into the coefficients alpha square plus alpha plus 1 is equals to 0. From this alpha square, from here alpha, and from this 1 is equals to 0. So now this product is 0. This product is 0 in the sense either this is 0 or that is 0. So what will happen? So A plus B plus C is equals to 0 or alpha square plus alpha plus 1 is equals to 0. So you just think about the second equation, alpha square plus alpha plus 1 is equals to 0. This alpha square plus alpha plus 1 is equals to 0 has, see, don't have a real root, it has a imaginary roots. Since it has imaginary roots, alpha has two possibilities and they are conjugate to one another. Okay, since this alpha is imaginary, if that alpha is a common root for these three, automatically they will have two common roots, not one common root. Is it clear? So here one more thing what I need to mention you is, if alpha square plus alpha plus 1 is equals to 0 in the sense, these equations have what? These equations have two common roots. And those two common roots are itself that alpha square plus alpha plus 1. Okay. So from this I have two ideas. If A plus B plus C is equals to 0, or what I need to say, alpha square plus alpha plus 1 just gives you that A is equals to B is equals to C. Okay. If alpha satisfies that alpha square plus alpha plus 1 is equals to 0, alpha will give you two values, and those two values are complex conjugates. Since those two values are complex conjugates, for sure every equation has those two roots as a common task. Every equation has those two roots as its roots. Since the roots are the roots of this equation, it is very clear that this ABC are in the ratio of these three, and this BCA are again in the ratio of these three, 1 1 1. This CAB are again in the ratio of these three, so 1 1 1. That in the sense A is equals to B is equals to C will happen. So either if A plus B plus C is equals to 0 or A is equals to B is equals to C, from algebra, some basic school algebra, it is very clear that A cube plus B cube plus C cube is equals to 3ABC. Okay, just have a look. This is the way to solve this particular problem, right?